Okay, guys, we are going to get started. So, um, it is class 4 of Python programming. As always, it's presented by me and Ottman. But today we don't have a TA, so Gotham will not be joining us. Usually he only joins us on Tuesdays. So, yeah. For some reason, class is a bit smaller today than usual. I'm not sure. I mean, like last Tuesday, I know there was like a lot more people, but it's okay. So the agenda for today, it's just mainly just review and coding. We have a midterm project coming up, which is it's building a calculator, which is super cool. You can use it to do your math homework. You can use it for whatever. So yeah, so for the review, I'm mainly just gonna go through the concepts that we learned through weeks 1 to 3, and then we are gonna have more coding time. So we had some coding time at the start because I recognize that you guys don't have a lot of time in this class to do some coding time. And we wanted to give you more time to, build your foundation and muscle memory. And you guys can also ask questions in the chat. Me during the coding times, me and Amin are free and willing to respond to them. So yeah. Okay, so we already did the coding time. It was about 15-20 minutes. So moving on, it's the review time. Okay, so firstly, um, to start off, we're going to review 4 types of data. So first up, we have int, which is short for integer. This is any whole number. So every single value in Python belongs to a few basic types: int, float, string, and bool. Um, int is just like a whole number. It can be positive, it can be negative, it can be zero, it's anything. Okay, next up we have float, which is a decimal number. So anything with a decimal point in it. Think of like price. Right here, it says 3.99. Now, if I'm going too fast, can you guys call me out in chat? I'll make sure to go a bit slower. But um, yeah, so moving on, we have string, which is text. So anything wrapped, like think of like a hamburger. Anything wrapped in single quotes or double quotes, it's going to be a string. Doesn't matter if it's letters, numbers, symbols, anything. The second it's in quotes, Python will treat it as text and it will be known as a string. And then finally, we have bool, which is short for Boolean. So there's only two true possible values for Booleans, which is true and false. So capital T and capital F is what you need to write if you're going to be using Booleans, and there's no quotes around them. So for example, with the variable is fun, if we set it to the equal to true, um, we use Booleans constantly in decision-making code, which we'll get later to today. So yeah. And then like ints are whole numbers, basically floating points are decimals. You can think of like that. Strings are quotes, bools, true and false. Think of it as a light switch. Yeah. Okay. If you have any questions, make sure to put it in chat. Okay, let's move on. I was gonna like showcase a little bit. I don't know if you guys need the showcase. I guess I could do a little bit for uh, 4 types of data. I mean, I'll be super quick. Like, if I understand if this is super old like stuff, I understand if it's like a little annoying. We have to keep going back to it, but I'll be super quick. So this is an integer. We set variable equals to a full number. We can set a variable named price to, let's say, 3.99 for a float. For string, we can have like a name, Gotham, which is who is our TA. And then we can have another variable is online equals false because Gotham is not online. Okay. And then it wasn't in this, it's not in the slideshow for today, but we also have the type function. If we print the type of age, we all know this 16, it's a whole number, it's an integer. We all know it, we all love it. So the type of age is int. Um, okay. Now, if instead of 16, we put 16.0, it's going to be a floating point number because it has a decimal. So yeah, that's basically it for the four main data types. It's going to be integer, float, Boolean, and string. All right. Oh, I wasn't presenting in full screen. I was. Okay, whatever. Now we have the input function. So let's talk about how we actually get information um, from our user while our program is running. And to do that, we use the input function. So the pattern for using the input function will always be the same. We are going to set a variable to be equal to the input function with prompt text. Um, and then we are going to have three pieces. So a variable where whatever the user types gets stored into your program. We can use it later. The input, which is the built-in function, which is in parentheses, which is always this spelling. And then we have the prompt text, which is an optional message. We can show it to the user right before they type it. Okay. So one thing I want to hammer home, like because it trips people up constantly, is that input always returns as a string. So like always, even if like we type a number 25, if we don't typecast it, typecasting is like putting the data type before. It's probably better to show, not tell. But if we don't typecast the input function, it's always going to return as a string. Okay. So if the user types a number like 25, Python will store it as like the text 25 and not like the number 25. And that's going to matter like when we talk about typecasting in a second. Okay. So Ottman actually wants to show you guys a cool demo that uses the input function. So let's see it.
All right. Can you guys see my screen? Sorry, that's my calculator from earlier. But so here's like a quick demonstration of like the input function that you guys have probably seen before, and then also using typecasting. So let's say we want to, track the money that we made from like a lemonade stand, right? So we can have like a lemonade stand earnings tracker. So the first variable we can have is the number of cups, like cups of lemonade, like that we've sold, right? And this one is, thinking about it, it can't be a floating point number. It will be an integer, right? For the number of cups that we sold. So it will be integer. So what we do in order to typecast is we put integer and then parentheses, and then inside the parentheses, we'll put our user input. And what this does is whatever the user puts in this user input is going to take the string. What this integer function does is it takes the string and it just converts it to an integer. So we could, enter the number of cups sold. And then we could also do like the price for each cup, right? So we could have a variable for like the price per cup. This way, price, it could be an integer, it could be a floating point number. Um, I think probably put float here, and then we could put our user input in the same way. What this float does is it takes the string in this user input, and then it converts it to a float. So now we could just enter the price per cup. And then what we can do is we can have a third and final variable, and this is where we apply some of our math too. We get a variable for our total earnings, and then obviously using math, right? Our total earnings will just be the number of cups sold multiplied by the price for each cup, right? So we can do cups sold, and then we write this asterisk here for multiplication, and then we have the price per cup. So this accounts for the entire price. And then at the end, what we could do is we could print, and here is where we can apply our knowledge of F strings, right? So if we didn't have F strings, this would look like, awesome job. You have earned, and then it would just be, you would have to add the variable total earnings, but that it just seems a little too cluttered and it's hard to, comprehend. So here we could use F strings, which is a little refining technique in Python. So here we write a little F, right? Hence the name F string. And then we put quotes after it. And then what we do is we can write, awesome job. You have earned. And then for any variable we want to put in this F string, we just put curly braces and then we put the name of the variable in here. So then when it's printing out this statement, the I guess contents that are stored in this variable, it will print out. So you have earned uh, total earnings today. So then if you want to test out our program, we can see, okay, let's enter the number of cups sold. So let's say business was kind of slow today and we sold 4 cups. Let's say the price for each cup was, $1. So obviously what we see, we multiply 1 and 4, and we get $4. So that's basically just user input. And with user input, you want to always make sure that you're typecasting, especially with the calculator midterm, like our midterm project, make sure you're always typecasting your user input. Otherwise, what's going to happen is you're adding strings together, and that's simply not going to work. You can't perform mathematical operations on strings. So just make sure to always typecast, especially for your calculator later today or next class. So that's just an overview of user input. Oh yeah, and I'll
Um,
also go through slides as well.
and can you throw the program in chat too, just in
All
case?
right, sure.
Yeah. If you guys want to like add on to like make tax, I guess you guys feel free to do so. We have another coding time coming up if you guys want to like add on to it. So yeah. Okay. So Amin's gonna go through the next couple slides, I think.
So we already went over typecasting, but just to kind of reiterate, we've always talked about typecasting with integers and floats, but we can also typecast with the other two data types, which is string and Boolean. So yeah, you could also do that, but just make sure that if you're typecasting with a Boolean, all values are going to return true except for a couple exceptions. For example, if you have like the number 0, it will output false instead of true. But you can also typecast with both of those other data types. It's just less common when you're actually applying it in your code.
I want to add on to the typecasting, sorry.
Yeah.
But like if you look at the example x equals 21, that's a string right now, even if it looks like a number. So if you do like int x to typecast it to an integer, Python will convert the string into an actual integer 21. So yeah, that's just like some basic knowledge and good to know.
Yeah. So the next thing we're going to be talking, or I guess revisiting, is math and Python. So obviously there are certain operations that you can perform on two or more numbers without any math module. Oh, sorry. So for example, we can do the basic, like the four like basic operations. We could do addition, we could do subtraction. So we can do addition like 5 + 3, and then we could do subtraction, 5 - 3, multiplication, 5 × 3, division, 5 ÷ 3. And then there's also, other operations. For example, floor division. What floor division is it takes the output, right? So for example, if we look at 5 ÷ 3, it's roughly equal to 1.67, right? But then if we perform floor division, what it does is it takes the quotient and it rounds it down to the nearest integer. So in this case, in 5 ÷ 3, we're going to round down for 1.67 and we're going to go all the way down to 1. Um, so that's what floor division is. It's basically, you could say it's a variation of the floor function, which we will go into that later with the math module. Next is modulo. What modulo does is it's related to division. What it does is it outputs the remainder that you get if you divide two numbers. So what I'm talking about is we look back at 5 ÷ 3. We see that so 3 goes into 5 one time, but then we also have a remainder of 2, right? Basic division. So here, that remainder of 2, that's what modulo expresses. It expresses the remainder when you divide two numbers. Um, and that kind of sets the basis for like checking if numbers are even or odd, right? Because any number that's even is able to be like, if it's divided by 2, it will have a remainder of 0. If a number is odd and is divided by 2, it will output 1. So you're able to check numbers that way. Uh, Next, we have some of the basic functions, other functions without the math module. So for example, we could take the absolute value of any number, right? So for example, if you guys don't know what absolute value is, basically it takes any number uh, in this function and it always outputs the positive version of that. So if you have absolute value of 5, it's just going to be 5. If you have the absolute value of -5, it's also going to be 5. So it's always positive. It can never be a negative output. We can also have we can also do exponentiation, where we have a base and then we raise it to a certain exponent. This is the kind of the framework for it. So for example, using the same numbers 5 and 3, we can have 5 as our base and then 3 as the exponent. So what that basically means is just 5 to the third power. So it's 5 times 5 times 5, right? If you guys don't know what exponents are, even though you probably do know, it's just repeated multiplication. So 5 times 5 times 5 will just be 125. So that is the power function. And then finally, we can round. So let's say you have a certain number that you want to round, but you want to round it to a certain number of digits. So in this case, we let's say over here in our example, we want to round 5.33. And what this one represents, it just means how many digits do we want to round it to, right? So in this case, we have 1. So that means we're telling Python, hey, take 5.33 and round it to 1 digit or round it to the nearest tenth, right? So here we're just going to output uh, one number after the decimal point. But if you did like round 5.3333 and round it to 2, then to 2 digits, then you're just going to have two numbers after that decimal point. So that's how the round function works.
Okay, awesome. I think I'll take it from here and I'll explain the math module next. Okay. Uh, okay. I think is it working? Okay. So like if absolute value round are like already built into like Python, right? So then why would we even need to import anything? Like you might ask yourself that. Well, like Python's built-in toolkit is like made intentionally small. So if we want to do like, I guess, more specialized math, like trigonometry, we reach for the math module because it's way easier. So to use it in one line, just one line at the very top of your file, you just import math. Um, that line loads like a whole library of tons of math functions that you're able to use. Once it's imported, every function is accessed with dot notation. So like as you can see in this math dot square root equals 25. Um, Notice how like it's 5.0, not 5, and that's mainly because like the math module, it mainly returns floats, even when the answer is like a whole number. We showed earlier that if we printed like 5 as a float, it returned as 5.0. So that's the main thing that's showcasing here. Key point is that just like import math at the top, access it with that notation, and uh, math functions often return floats. Okay, so let me pull this up. Let me show you guys. Just give me a second. Sorry. Okay. Oops. Okay. So, another like something super useful to know. So let's just import the math module forth. It's just import math. Something super useful to know is that if you want to access, like you want to know the functions, I know Otman mentioned this in an earlier class. Super helpful. If you just want to know like what the functions are in there, you just do print dir math. And there's a super long list of all the functions. Um, I'm not sure how, okay, wait, okay, regardless. So if we actually want to like use the math module, ton of stuff that we can use. We can set, I mean, there's a showcase there. Set result equal to math dot square root 25, I believe. Print result. And then print it 5.0. If we want like an irrational result, we can do print dot like math dot square 2. And yeah, it just like it's not gonna show, yeah, but regardless. Um, so this is the contrast between like a clean floating point number and super like long irrational decimal. Okay. So now that like math is imported, we can tour the functions you'll use most. Um, so we have, let's see, we have ceil, the ceiling function, which it rounds up. So if we print ceil 2.1, I think this should work. I'm not sure why it's okay. That's weird. Um, but anyway, there's like tons of functions that you can use within the math module. Like fa the factorial function. And yeah, there's a lot of cool stuff that you can play around with. A module in Python is just something like it's a library with tons of functions within it. You just play around with it. Uh, Last time we showed the random module. Math module is pretty important. We can use it in our calculator, but that's the main reason why we're using it. Um, okay. So here is all of the different functions that we can use in the math module. Okay. We have fabs, fmod, pal, square root, ceiling, floor, mod. and factorial. I guess I should probably show you guys a demo. So I'll do print dot tabs -5. I tried to input the module. Okay, so fabs returns the absolute value of x as a floating point digit 5.0. Okay. Uh, f mod returns the remainder when x is divided by y. So we can let's just do print math dot mod 52, which is 1. Another remainder divided by 2, or when 5 divided by 2, it is 1. Oh, okay. So that's just some of the functions that you can use within the math module. I think we'll move on because it does get like pretty boring. It's just like an external library. It's not that like important realistically. Um, okay. So,
Should I screenshot it?
oh yeah, yeah. You just could give me some confirmation in chat if it's good. Okay, so Otman wants to show something cool that you can do with the math module. I think I'll hand over the reins to him for a second. Something cool that you can implement in your calculators that we will use in a week. So yeah.
Okay, so I just want to show you guys a quick program that utilizes certain components of like the math module so you can find like the area of a circle, which is going to be my program. Let me just clear my outputs. Okay, perfect. So the first thing we're obviously going to do is import our math module. Otherwise, everything else is not going to work without it. And for this program, let's make it a little more difficult and let's just implement um, user input. So for our radius, we're going to have user input. It would be enter the radius of your circle. But obviously, we need to make sure that we want to typecast this into a float. So yeah. And then now what we do, so the area of a circle is pi r squared, right? So you probably know where this is going to be heading, right? So if we want to find area of the circle, so the first thing is pi as a number is not built into the Python function, or is not really built into like regular Python. So when you import math, you're able to essentially you have a new option. So what now you can do math.pi. So what this does, it quite literally gives like it gets pi into your program. So it will be pi, and then now what we're gonna multiply by is the radius squared. So we can use once again using our math module, we can do math.pow. And if you guys remember like the general structure of the power function, it's going to be base and then it's going to be exponent after. So in this case, we want the radius squared. So our radius is going to be our base, and then obviously we're going to square it. So this becomes the area of our circle. And then all we got to do is just print, uh, we could write, and we can obviously do some F strings as well. The area of your circle is area circle, this variable, squared units. Let's just say units. So we can go ahead, we can test this out. So let's say the radius of our circle is like 5, for example. Then the area of our circle would be this whatever, right? Now, this might be a little hard to look at. So what you could do is you could kind of, I guess, modify the area of a circle, like your variable. And what you could do is you could round it, right? So we could reassign it and we could round the area of our circle. So we could round our variable and then we could like round it to, you know, 2 decimal points, three. In this case, let's just do maybe one just for simplicity. So if we did the same thing here, then obviously you would see it would be 78.5 instead of whatever hunk of a number that we had before. So yeah, so that's basically just a little bit of work with um the math module. Just make sure you don't necessarily need to have pi in your calculator, but it is nice to have some experience with like, let's say the power function, maybe even like what Gavin showed you, like ceiling, floor, etc. So
Okay, bet, bet. So it's coming up to 4 o'clock, which means we don't have a lot of time left for our lecture. I mean, we kind of have to go a bit faster. Um, because I still want to squeeze in some more coding time after the lecture, and we also have a pretty cool booklet blend. But okay, so I don't know if you guys necessarily need a demonstration, I guess, but I guess like I guess I'll just talk. So if we shift into a decision-making code, we have conditional statements. And this is how like programs make choices based on data using the if and else arguments. Um, we use them combined with comparison and logical operators. So let's take the example here. It says a equals 10. We set variable a to the integer 10, set the variable b to the integer 20. If a equals b, we will print the statement yes, string yes. If the if statement is incorrect, we will print no. Okay. So if a equals b, well, let's check. Is a equal to b? A is obviously 10, B is obviously 20. This is obviously incorrect. So we are going to skip the if statement, go straight to the else statement, and print no, because no, they are not equal to each other. Notice the double equal sign. This is the comparison. Like that's how you compare values. It's completely different from a single equal sign, which is meant to assign values as shown here. Mixing like these two up, it's like super common. Like it's just super common like bug in your code. So make sure to look out for that if you find any mix-ups. Um, and yeah, the condition after if, well, okay. Yeah, the condition after if always has to evaluate to a Boolean. So true or false. So that's why Bool matters so much. Like every if statement depends on it. Okay. Now let's do a super quick showcase. This will be super quick. Uh, there we go. Let's add a cell, and then let's set two variables as shown up there. A equals 10, B equals 20. If A is equivalent to B, notice how we're using the if statement. We'll print yes. Else, meaning if this doesn't happen, then this will occur. If A is equal to B, but that's not true, the obvious answer is that A is not equal to B. So think of this as being if A is not equal to B, then this will occur. So then the print statement of no will occur. Okay. Now let's run the statement or let's run the code. It's gonna print no. Now let's flip it. So if we do A equals 20, B equals 20, if A equals to B, let's print yes. Else, oops, I accidentally ran it. Print no. Let's run it now. So this no is from our statement up here. This yes is from our statement here. Um, okay. Wait, Otman, I forgot to say, but can you send, do you still have the circle program, circle area program? If
Yeah,
you
I think
do,
I do.
yeah, can you send that in the chat? Because
Sure.
that would be super cool. Okay. Um, yeah, so this is basically just conditionals. It's pretty easy. If this if statement is true, this will happen, else this will happen. Okay. Now, hmm, okay. I think we gotta move on, but there isn't much time left. Comparison operators. Okay, this is like pretty simple. Comparison operators, you just use them to compare things to each other, like inside of an if statement. Um, you can also use them to print something out, like you get a Boolean return. Like, okay, it's, I'll just do create a cell for right here. So yeah, you can get like a return, return a Boolean. But like realistically, like this is pretty intuitive. So if you guys want to take a picture, feel free to, but basically greater sign, then the equal sign means greater or equal to, less the less than sign, and then equal sign means less than or equal to, not equal to is exclamation mark and then an equal sign. And basically you just use this within if statements. So if you use a lot of if statements, these will pop up like 100%. Okay, we have logical operators. We did cover this last class. It should be pretty fresh in the brain. Um, okay, okay. I think lecture for today, like I think we should probably be like we should be pretty like familiar with everything. I honestly think it would be more beneficial if we took like our 20 minute coding time right now. Ottman sent um a few like things that you can add on to if you want to add on to them, or you can just copy it down. That's super cool. I'll try to send a few programs in chat that you can copy or you can add on to or do whatever you want to do with them. But yeah, we're gonna start our 15-minute coding time. And yeah, feel free if you guys have questions, ask them in the chat. That'd be super cool. Okay. Okay, we're gonna do a booklet at the end of class. Right now, it's like a 15-minute coding time again, right after our lecture. Um, what would be like kind of cool and kind of helpful is that like if you guys tried to make the calculator, like it's not like official, but like getting like we're not officially like starting. Yeah, okay. Like we're not officially like starting the calculator because like not a ton of people are in class today. But if you guys like could try to make a calculator, that'd be super cool. It's just a good project to start doing. I'm showing. I made like last class. I made a pretty cool program. It's like a movie theater program. So if you guys could just like maybe copy it, that'd be cool. And if you are copying it, make sure to understand what it's saying. Like, make sure you know if the age smaller than 5, like what all this means. Because I don't want like you guys, I want it to be fresh in the brain. I want you guys to understand what we're writing. Because this mainly this week was just review. Next week we're gonna be moving on to new things. And yeah, so starting now, we have 15 minutes of voting time. All right, guys. So we're coming like to the end of our next coding time, our second today. Hopefully you guys made some pretty cool stuff. I know me and Ahmed sent a lot of programs in chat. I think we're gonna take like maybe 1 or 2 minutes, and then we're going to play a Book It. So I know there's not many people in call, but if everyone can join the Book It, that'd be super cool, super awesome. And yeah, the recording will be on after class, hopefully. Fingers crossed. So that will be great. Okay, that's it. All right. I think we gotta start the Book It, otherwise we're gonna run out of time. So okay. So what do you guys want? What you guys choose? You guys want Fishing Frenzy, Dinos, Tower Defense? Want Dino? Fishing? I'll do Dino because it was said first. Um, okay. Let's do 7 minutes. Okay, I sent the join link in chat if you guys want to join. Okay. We should have 6 people. So please join, please join. I probably won't start until everyone's in, but yeah. Okay. C5. I don't know who's not in, but I think we gotta start it. Otherwise, we're gonna run out of time. Okay. Shit, no. Holy. Tarvanon on top. Okay. Tarv is in the lead. That is goaded. 325 by a Tarv. Oh my God, everyone's investigating a Tarv. I don't think a Tarv is cheating, but okay. Yanni is #1 now. That is pretty goaded.
Keep in mind they could be using hacks.
Yeah, they could, but a Tarvanand is I know a Tarvanand. He wouldn't use hacks. Tarv, you better not use hacks. Satvik is still 0. I wonder what's going on there, but it's okay. Hmm. Bro, a Tarvanand on #1 again. Oh my Lord. Okay, we got 5 minutes left, guys. Come on. Lock in. I'm gonna bring us to the end of class. Oh my Lord, the Tarvanan, 1.4K. Sam just caught in your mouth cheating. Yo, and Tarva almost at 2K. Okay, I like to see it. I like to see it. Yo, Tarvanan at 2.5K. Yo, Tarvanan's the GOAT, bro. Oh my God. 4 minutes left. Come on. Chop chop, guys. Yo, everyone is investigating Atar, man. Atar, you better not be cheating. Holy cow. Sam just got in your mouth cheating. Guys, Atar is not cheating. You guys keep investigating him. He's just good at the game. Oh my gosh. All right, whoever wins this has some free bragging rights for the rest of eternity. Tarvanon, are you cheating? You have 10K. Wow.
Yeah, he's definitely hacking.
No, I don't think he's hacking. Tarvanon, you can private message me if you're cheating or not. I won't reveal it. That's crazy. Maybe he's just the GOAT.
No, I don't mean like hacking within the game. I mean
Oh,
like
you think
literally JavaScript hacking.
you think he's actually cheating? Like,
Yeah.
I don't know. I don't think he would do that. I know it's hard. Hey, but maybe he is, you know? He's a little sneaky about it. So, guys, 1:30, 1 minute 30 left. Tarvanon is still the king. Wow. Okay. He is just cooking. No one can stop him. Guys, 1 minute. 1 minute. Tarvanon is closing in on 20,000. Holy. 21K. Tarvanon. 30 seconds left. Tarvanon caught something cheating. Wow. All right, 20 seconds. Tarvanon's still number one. The GOAT. There's a close race for third place, but this is gonna be final. 5 seconds. Three, two, one, and Sam third, Yanni second, and
Honestly,
no other than a
good enough.
Tarvanon at first. All right, guys, that's the end of class. Feel free to leave if you have any questions. Feel free to stick around. But other than that, yeah, you guys are free to leave.
Goodbye, guys.
See you guys. If you guys didn't know, Ottman was a Tarvanat. So yeah, I don't think he was cheating, but it was yeah. Ottman was a Tarvanat. So he did pretty well. As we can see, first place by a wide margin. But you guys also did really well. So really cool to see how you guys have progressed. But that's the end of class. Feel free to leave.